Okay, let's go over a little bit of the quiz. Number one, I'll go kind of quickly. Most of you guys did really well on number one. F of 2 is where this blue dot is, so that equals -5. The limit as x approaches 2 from the left, as we approach this white dot, we're approaching -2. As we approach from the right, we're also approaching -2. And that means the limit as x approaches 2 is -2. By definition, if the left limit agrees with the right limit, then the limit does exist. On question number 2, the limit of f of x as x approaches -1 does not exist, and you were supposed to explain why. The reason is that the limits from the right hand and the left hand sides do not agree. So the best answer would have been to say the right and left hand limits do not agree. And then that you had shown me that. This would be like an excellent answer. X approaches -1 from the left of f of x equals -1. And the limit as x approaches -1 from the right of f of x equals, what is that one from the right? -3. So therefore the limit does not exist. There's a lot of confusion on the vertical asymptote question, the horizontal asymptote question. A lot of you seem to think that there's only a horizontal asymptote if there's a dotted line. No, there doesn't have to be a dotted line. That's kind of a courtesy. Others of you thought that there would only be a horizontal asymptote if the function approached 0. You can have a horizontal asymptote at any number. The definition of a horizontal asymptote is the limit as x approaches either positive or negative infinity of f of x equals a number, where L is a number. Or the limit of f of x as x approaches positive, negative infinity of f of x exists. You could also say it that way. If there's a limit as you go towards infinity, then there's a horizontal asymptote. As x gets bigger and bigger and bigger, the y values get bigger and bigger and bigger. Therefore, there's no limit. As x gets smaller and smaller and smaller, I'm sorry, I said that wrong. As x gets bigger and bigger and bigger, the y values get smaller, smaller, smaller. As x gets smaller and smaller and smaller, so do the y values. So there's no number that we're topping out at. So a good answer to this would have been the limit as x approaches positive or negative infinity of f of x does not exist. And therefore you can't have a horizontal asymptote. Okay, number 3, when you plugged in, you got 0 over 0. So then their next step was to see if you could factor and cancel. And sure enough, you can. When you factored and canceled, you got x minus 7, x minus 4. And the x minus 4 is canceled. X minus 7, if you plug in, you get 4 minus 7 equals -3. Limit of sine 7x over 2x as x approaches 0. You're looking for that sine u over u. So what I would do is I would pull out that 2x because I really want a 7x there. So I'm going to do 1/2. That's how I'm pulling out the 2 from the 2x of sine 7x over x. See how that's exactly the same as the function I had a moment ago? And then what I need here is I need a 7 on the bottom, right? So I'm going to multiply top and bottom by 7. That gets me the limit as x approaches 0 of, I'm going to put this 7 over here, 7 over 2 sine 7x over 7x. And limit of 7 over 2 is 7 over 2. The limit of sine u over u is 1. So my answer is 7/2. Moving on to the back, you had number 5, the limit as x approaches 0 of x cubed plus 6x over x plus 8. If you plugged in, you got 0/8, which equals 0. Please make sure you write the number 0 for your answer. Number 6 was a challenge, apparently. But most of your mistakes were just minor mistakes in number 6. So I'm going to go ahead and just start with, when you plug in, you get 0/0. So we need to use the conjugate. So I'm going to multiply top and bottom by root x minus 6 plus 1, because I want to change this sign to get the conjugate. The reason we do this is when you have a minus b times a plus b, the answer is a squared minus b squared. So what you get is the limit as x approaches 7, and a squared would just be x minus 6. 1 squared is 1, and it has to be a negative. And then on the bottom we have x minus 7, and we still have this because it didn't cancel. X minus 6 plus 1. And then can you see that x minus 6 minus 1 is the same as x minus 7? So these will cancel. This was a pretty common mistake. You forgot to do the 1 over. So this leaves you with 1 over root x minus 6 plus 1. And when you plug in, let's see, that was x approaches 7. You get 1 over root 1 plus 1, which is 1/2. Let's see. Cotangent is -1, and the next one, when you plugged in, I believe you got, this is number 8. When you plug in for number 8, you get -4 plus 7/1, and that equals 3. Number 9, when you plugged in for number 9, you got 8/0, and that's DNE. You were right, it is a vertical asymptote, but the answer to the limit problem is DNE. Number 10, if the numbers in the chart are approaching 1 from either direction, like this was 1.001, I think, and this was 0.99, as you're getting close to this DNE place, you're also getting close to 1. So that was your limit for number 10. And let me see if I have time for the level 4s. I do. Okay, so the level 4s, the first one, they wanted you to draw a graph where the limit did not equal the function value. And I was a little liberal in grading these. What they're actually looking for, I guess I mean the AP writers, College Board writers, when they ask this question, what they're actually looking for is a situation like this. But I didn't write the question very well. I should have said sketch a graph that shows a situation where f of c exists and the limit exists, but they don't equal each other. So I was kind of looking for, you're telling me that the limit did exist and that the function value did exist, but they didn't equal each other. So in this case, f of 3 equals 4, and the limit as x approaches 3 of f of x equals 2, and they don't equal each other. And I was looking for you just to kind of write that out. Number 2, boy, this was really testing your piecewise knowledge right here, and you had to get it all right to get any credit. So the limit as x approaches 3, that was just a little bit of a trick question. When x approaches 3, the function is negative 2x, and it's continuous there. So you just plug in, you get negative 6. X approaches negative 5 from the left. Well, as we're coming toward negative 5 from the left, we have some sort of function that looks like y equals negative 2x, right? So all we have to do is plug in from the left. We're going to approach negative 10, but we're never going to get there. And then from the right, we have a function that's positive. So when I come from the right, I'm coming this way, and I would be approaching it from the right would be 15. H of 5 is 15 because this is x is greater than or equal to 5 for y equals 3x. So that's where we would plug in to get our function value. And then does the limit exist as x approaches 5? I think we showed right here that it doesn't because we have a different value from the left and the right. Okay, so that limit does not exist. That was a super speedy run through of your quiz, but hopefully it helped you with finding and explaining some of the things that might have been a question. That's it.